All right, so I'm going to be going over some problems from 7.1, so from the week 11 homework. So we're going to be talking about ratios and proportions. Um, yeah, so some vocabulary terms that I'm going to mention. I'm going to go through the different kind of problem types that we have here. So first off, so using some ratio language. So let's go ahead and read this. Fill in the blanks to express the quantities given in ratio language. Ratios must be expressed in simplest form. Number of miles driven in a week. Okay, so Annabelle 24, Scarlett 56, Daniel 40, Kylie 8. For every blank miles Annabelle drove, Daniel drove blank miles. So we're trying to compare two quantities here. We're trying to compare the number of miles that Annabelle drove and the number of miles that Daniel drove. Okay, and so the order that we are doing that here is Annabelle to Daniel. So that's 24 to 40. Could also do this as a fraction if we prefer to represent our ratios in that way. Either way, we're going to be simplifying this. So we want to find the greatest common factor here between these two numbers. What can I divide them both by? That's the largest. And just sort of looking that, I believe that's going to be 8. So I divide both of these by 8, and we end up getting 3 to 5. So using the language here, that would be for every 3 miles that Annabelle drove, Daniel drove 5 miles. So for every 3 miles, 5 miles. We'll go ahead and submit that, and hopefully we've got the right answer. All right, let's go ahead and do one more of these. Okay, number of Twitter followers. So for every blank followers Claire has, Lincoln has something. So we're comparing Claire and Lincoln. So that's 45 to 63. Again, we can do this as a fraction if we prefer it that way. And we need to reduce these. So again, we need to find the GCF, the greatest common factor, and divide that out. Greatest common factor here, I believe, is 9. Divide both of these by 9, we get 5 to 7. So for every 5 followers that Claire has, Lincoln has 7. For every 5 followers Claire has, Lincoln has 7 followers. All right, and again, hopefully we got that right, and we did. Let's go ahead and clear this, and let's go back to the next problem set here. So the constant of proportionality from context. Okay. The table below shows a proportional relationship between V and W. So proportional relationships means that if I write ratios here, they're going to be equivalent. Find the constant of proportionality V to W. So when we say V to W, we're talking like this, or V to W. We're going to do it in the fraction format because we want to be able to reduce that to a whole number or fraction if we can. So simplifying that, we have I apologize, that's actually going to be backwards. So going from V to W, we're actually looking for 7 times what constant is going to equal 56. So V times the constant of proportionality equals W. So when we're talking about a proportional relationship with a constant of proportionality, there's kind of 2 ways to think about this. So there is one that however we divide these things, W over V is going to equal some sort of constant of proportionality. We'll call that K. That means that if we do V times K, we get W. That's just some algebra to arrive at this relationship. So essentially we're doing V times what is going to equal W. Okay, so that's what we're answering about this sort of first one here. V times what is 56. So for this one, it's 8. 7 times 8 is 56. And then kind of following through with these other values as well. 9 times what is 72. Again, that's 8. Should be a constant. This should be the same number for all of these, but let's just double check it. 11 times what is 88. And yeah, it is 8 again. So this right here is our constant of proportionality. Let's go ahead and clear that. 8. Okay, let's go ahead and move forward. Next problem. All right, one more. Got a proportional relationship between Q and R. So again, we're looking at Q times what constant is going to equal R, or R over Q equals the constant of proportionality. So either one of these two things can kind of help us figure this out. I'm going to go ahead and do it a different way this time, R over Q. So 16 over 112. If we reduce that, those might both be divisible by 16. Let's just think about that. 112 divided by 16. Yeah, so both of these actually are divisible by 16. So this actually reduces to 1/7. Let's just make sure that all of these do reduce in that same way. 18 over 126. Those are both divisible by 18, I believe. 126 divided by 18, yep, that's 7. So this reduces to 1/7. And then the last one over here, 20 over 140. Those are both divisible by 20. So we get 1/7 again. So all of these ratios for each 3 of these entries were the same. So our constant of proportionality here is going to be 1/7. So 1/7. So in general with these problems, the thing to keep in mind is your sort of x variable, y variable, independent, dependent. So this is x, y. It's always that y divided by x is equal to your constant of proportionality, or x times the constant of proportionality equals y. So those are the ways we're going to be thinking about it. So whichever one is the x, the independent, the one in the first column, and whichever one is the y in the dependent column. All right, and let's go ahead and move on to the next problem set, do a couple of those as well. Proportional reasoning, fractions, and decimals. Okay, let's go ahead and read this one carefully, make sure we understand it. The length of a cell phone is 1.6 inches and the width is 3.4 inches. So we got a 1.6 by 3.4 inches, and that's our cell phone. The company making the cell phone wants to make a new version whose length will be 1.36 inches, assuming the side lengths in the new phone are proportional to the old phone, will be the new width. Okay, so so we want one that's now 1.36, and we want to know the new width. So knowing which parts correspond, right? This is my length and my length and my width and my width. So the ratios of the lengths and the ratios of the widths have to be equivalent to each other. So we can set up a proportion here. 1.6 over 1.36 is going to equal 3.4 over W. So this is one way to set this up. There are several others here. But what I did was write the ratios of my lengths. So the length of the larger phone divided by the length of the smaller phone equals the width of the larger phone minus or divided by the width of the smaller phone. So keeping those ratios consistent, larger one on top, smaller on the bottom, length over length, width over width. So let's go ahead and solve this. So we're going to do cross multiplying. 1.6W equals multiplying that out, I get 4.624, and then we need to divide both sides by 1.6. So divide by 1.6. So I get 2.89. 2.89. All right, what is the width of the new phone? And it doesn't tell us about rounding or anything, so we'll just type that in. 2.89 inches. Submit. Fingers crossed. Yep, got the right answer. Okay. Let's go ahead and do one more of those. All right, so here is a table. So we can do this in a couple different ways. The number of miles that Nolan drives is proportional to the amount of gas he used, so the number of gallons of gas that he uses. So we can use a constant of proportionality. So we can know that if we take, this is my x variable, my y variable, if I do y over x in these situations, that's going to equal my constant of proportionality. and I should get the same constant for all of these. So I could just sort of quickly demonstrate all of those here. So 1529.3 divided by 41, 16003.9 divided by 43, and 1753.1 divided by 47. So doing all three of those divisions, hopefully you can see that there on my screen, they all give me the same constant of proportionality of 37.3. So 37.3, and that was taken by doing miles divided by gallons. So that would be in miles per gallon as a rate. So I could use this to help me answer the question at the bottom, this being my constant of proportionality here. I could figure out how many miles he could go on this amount of gas, or I could set up a proportion. So I'm going to kind of show two ways. I think the easy way to just kind of go straight forward here with a problem with getting a solution would be to use a proportion. So I can just take one of my entries here, 1529.3 over 41. This is miles over gallons. That's going to equal miles over gallon, unknown number of miles over 49.2 gallons. So gallons on bottom, miles on top, miles on bottom, miles on top. Consistency of setup. Not the only way you set it up. You could set this up differently as well, but this is the way that I decided to here. Cross multiply 41x equals 1529.3 times 49.2. So that's 75,241.56. And then I just divide by 41. 1,835.16 miles. So that's the number of miles that we would be able to drive there. 1,835.16. Okay, let me go ahead and clear this work here and just kind of go back to the other method. So the other method, we discovered that there was a constant of proportionality of 37.3 miles per gallon in this situation. So we know that there's this relationship, y is equal to x times k. So y is equal to x times 37.3. In this case, my x is gallons used. So I could just take this amount of gallons of gas, plug it in here. 49.2 times 37.3. And I end up with the same answer, 1,835.16. Kind of two different ways to do that. Again, doesn't really matter. I'm going to use the proportion method from here on out, but certainly a valid way to go about it by using the constant. Okay, let's clear this. Let's go ahead and go back. Let's go to our last problem set, comparing rate of change. All right, Lily was comparing the price of salmon at two different stores. The graph below represents the total cost in dollars and cents per pound of salmon. Okay, so y is cost in dollars and x is pounds. Okay. All right, so we have these two data points. So at one store, it was 5 pounds for $53.55, and this other store, oh no, I'm sorry, these are two different. This is two different data points for the same store. 5 pounds for $53.55, or 10 pounds for $107.10. Sorry guys, feels late right now. We could find some rates on this, so we could take y over x and just sort of compare the rate on this. So 107.10 divided by 10. That would tell me that this is actually $10.71 dollars per pound. Dollars on top, pounds on bottom. This is dollars, this is pounds. So that's that rate. And then the other one should be the same, but let's just double check this. It's $53.55 for 5 pounds. Yeah, it's the same rate. That's 10.71. So $10.71 per pound. So that's our rate for the grocery store A, super grocery A. And we want to compare this to the other place, the other situation. Okay. The table below represents the total cost in dollars and cents that it costs for X pounds of salmon at super grocery B. Yeah, so I'm thinking these rates are all going to be constant here, but let's just go ahead and divide these and just make sure. So 1364 divided by 2, that tells me that this is $6.82 per pound. I'm just going to quickly do these other ones. Okay, that's the same thing. 27.28 divided by 4. Yeah, that's the same thing. 34.10 divided by 5. Yeah, so all of these were the same rate of $6.82 per pound. So this is the rate at super grocery B, and this is the rate at super grocery A. So it's cheaper at B than it is at A. So let's go ahead and see what questions they have for us about this at the end. How much would you save per pound if you buy your salmon at super grocery B compared to super grocery A? Okay, so it's less, so let's actually just find the exact difference here. So we would do $10.71 minus $6.82. Have to borrow here. So it's 9, and then this is 9 and 16, so 8. That's $3.89. Let me just confirm that with a little calculator action. Yep, $3.89. So we are going to save $3.89 per pound. Interesting. 3.89. Another way that we could have done this here was comparing specific entries, like here and here, where we did the same rate or the same number of pounds, and just sort of looked at that and found their difference. But I think just calculating the rates and saving was the way to go. Okay. These problems can take some time here. Let's go ahead and look at the next one. All right, so 2 friends, Lucy and Eva, took summer jobs. The equation y equals 16.6x represents Eva's earnings in dollars per hour. Okay, so right here, y represents dollars and x represents hours worked. Okay, so that means that this right here is her rate. This is the amount of dollars, 1660 per hour. That is her rate for, I guess, Eva. Okay, the graph shows Lucy's earnings. So let's check out Lucy's earnings on the graph here. Having trouble scrolling. Yeah, there we go. All right, Lucy's earnings. So we have 2 data points for her that we can use to calculate the rate. In this case, this is a proportional relationship because of starting at 0. So we can just simply divide these y over x. So 392 divided by 20. That is 19. So this one was a rate of $19.60, 19.6. So 19.60 per hour. And this one should be the same, but let's just calculate it. 196 divided by 10. Yep, same rate. So 19.60 per hour. Okay, so comparing these, so this is for Lucy. Lucy. Let's just like drag this over here real quick. And let's erase all this other stuff. Just sort of comparing these so we can talk about it. Lucy is obviously earning more money, 1960 for 1660, so it's actually $3 more that Lucy is earning per hour. How much less per hour does Eva earn? Oh, so Eva earns $3 less, $3 less per hour. So it's about calculating the rates and then comparing them. Your rate may be an equation. It may be a graph, maybe a table. You got to calculate those rates or identify those rates wherever. So the rate in your equation is going to be right here. It's that constant of proportionality. Y equals k times x. Whatever that is the rate that you're calculating, y per x. All right, and that's it. Feel free to watch the videos here, help videos. If you need some extra assistance, those are always there available to you, or come to office hours. See you guys later.